convection currents. Our objective today is that we will learn how convection creates motion under and on the surface of Earth. Okay? Your essential question is, how do convection currents play a role in the ocean and atmosphere? So, we are going to start off with a demonstration. If you look at the orange paper that is on your table, that's what we're going to look at first. So if you look, it says, the purpose of this demonstration. I know this is a lab. I used to do it as a lab, but people are crybabies, so we don't do it. I don't do it in the lab. They say it's too hot. Alright, so we are going to model a convection current, and we're going to demonstrate our understanding of why convection currents occur. So if you look, the procedure says we're going to fill one baby jar with cold water, which I've already done, one with hot water. We're going to place an index card on top of the hot water, and we're basically going to be putting both jars on top of each other and seeing what happens with the water when I remove the index card. Now, we are going to put the hot water on top first and the cold on the bottom. So what I need you to do while I set this up is I want you to copy that table on page 136. So copy that first table on page 136. And then I want you to think about what's going to happen in just a second. Hot on top, cold on bottom.
We drop both tables?
Just do the first one first. Okay, so like I said, basically what I'm going to do is I'm going to take this hot water and I'm going to put this index card on it and invert it. Then I'm going to put this right on top of this one. And what I'm going to do is I'm going to take this card off in just a second. Okay? What do you think is going to happen?
Hot rises.
Now, why do you think they're not going to mix?
Because one's more dense than the other.
Okay, which one is more dense than the other one? The hot is more dense?
So we're gonna switch.
So if you're saying that the hot is more dense,
No, it's
more
less
dense
dense.
would
We
sink.
can do both.
Mine is less dense.
So you think the hot water is less dense?
Yes.
So they're not going to mix?
They're gonna-
Well, they might mix just a little bit and then like.
Okay, we'll see.
What a magician.
So, what do we see that happen?
Stay up.
It says separate, right? So, on your table for observations, write down what you see. If you want to use some colors and actually do a drawing, you can do that too.
And show with the other stuff.
Hmm?
It says it in the other page. Talks about it.
Oh, that's fine. If we didn't have the CPR, you'll want to look at that first, but I don't want you to just waste time. Okay, so on observations, Liliana, what'd you put? Huh? would you put? What is your observation? What do you see? Speak a little louder. It's not doing anything? Okay. Jesus?
Those waters stay in the same cup.
Both water stayed in the same cup. Antonio?
The hot water stayed on top and the cold stayed on bottom.
Hot water stayed on top of the water. Okay. So, if you look at question 1, it says what happened to the colored water. So, right, number 1, you're answering these questions along with it. So, what happened to the colored water? It stayed on the top. Incomplete sentences, please, so you don't have to copy the question. Number 2, why do you think this happened? So, why do we think that the hot water stayed on top, Tristan?
Because it's less dense.
Very good. Because it's less dense. Isn't density the reason why things sink and float? Okay, so it's less dense, it's staying on top. Alright, number 3, what do you think will happen if you place the cold water on top? Okay, Juanita? It will sink down. So if it sinks down, yeah, okay. So it will sink down, so what do you think is going to happen to coloring wise?
It's gonna rinse it.
Okay, Juanita?
Oh, I'm sorry. It's over.
It will mix? Alright, so that's what we're going to see next. So after answering those 3 questions, go ahead and copy the next table while I set this up.
Is the jar really that hot?
It's not really hot, but people are crybabies. I mean, it is a little bit what, if you put a paper towel, you should be okay. It's just the gloves are easier to take on and off, that's why I do it that way.
That's what I do with my soap on top of my toilet.
Huh?
That's what I do with my soap after I get up.
Yeah. I mean, it is hot, but you can deal with it. It's just kids really didn't want to deal with it, and I was tired of hearing crybabies.
Come back home with 30-degree birdies.
The water's not boiling. It's just really hot. I probably take showers with this temperature.
Mr.
I like
Mendes,
really
I
hot
was,
showers.
I was taking a shower, it was really hot, and then I was standing up, and then
No, you
everything
were
was
laying down.
well, I was standing up.
She could be taking a bath.
I didn't think
Yeah.
about it sometimes.
And then it was all very hot. I couldn't even breathe. And then I went down to close the little faucet thing, the bottom, and the bottom was really full so good.
Mm-hmm.
Is it because of convection or something?
Yeah, basically, because hot water's gonna stay at the top. Have you ever gone, whenever you go to the beach and you get into the ocean?
Yeah.
Aren't your feet colder than your
Yeah.
top?
Yeah.
Yeah.
Because
That's why when you
cold water's at the
sunburn,
bottom.
when you sunburn, you go
No,
to the
I'm
bottom
talking
of the
about
water.
the air and
Same thing with you.
Why would you drink it though?
That's what you take.
Alright,
That's what you take.
so-
Yeah.
Let's focus. So now we're gonna put, or I'm gonna put the cold water on the top. So our question, what we're gonna look at is we're gonna see what happens. And y'all said that y'all think that they're gonna mix, right? So I want you to really pay attention to what happens, and I want you to pay attention truthfully up there, because you're gonna see it a little bit better. I want you to see how they mix. What do you see is happening? What's the type of movement that you see? Alright? So does it just drop straight down? Does it go in a circle? What does it do?
I look at a circle. Because conventions are circle.
Oh, it's pretty cool. It's evil.
Alright, so go ahead and write your observations.
That's pretty cool. More blue water.
Alright, so now what happened to the colored water, Mariano? So the colored water is at the bottom, so what happened to that colored water? It spread and went to the top. Okay, very good. Yes.
Would it be different if the water was like hotter, like real hot, like and the cold water was like real cold? But would it be like mix more, or it would just be like that same?
You would have still the same thing, because the hot water is still gonna wanna go up and the cold water is still gonna wanna
Yeah,
come
but
down.
like is it gonna show more clear water on the bottom, or no?
No,
The
you
food
still
color
get some,
mixes it.
because,
The food
food
coloring?
coloring, the food coloring just mixes throughout the water.
Oh.
Yeah.
But what if it didn't have like the food color? Will the top still be hotter than the bottom?
Yes. Then you would be able to like touch it and feel.
Would this
Alright.
work with different liquids? Like, let's say water and a different liquid?
Any type of liquid, any type of substance,
Similar.
hot is always less dense than cold. And reason for it is because think about it. When you have temperature has to do with the particles, okay, of anything. So when particles are cold, they're moving, but they're not moving very fast. So think of a solid. Solid, we could say that it's at a colder temperature because that's why it's a solid state. And they're really, really close together for the most part, right? And then as they heat up, think of just liquids, think of water, it goes into a liquid state, so it has a little more space. If it has a little more space, then it's less dense, right? And then if it has a lot of space, it's much more less dense, correct? Well, when particles are moving, they're moving fast, meaning they're not going to be standing really, really close together. So you end up having less density because they're spreading apart because they're moving so much.
Is there any like liquid would be even less dense than the hot water? Just
Yeah, like if I have put oil in there, the oil is going to float in the water. So, and even then, oil will float over hot water because oil is still less dense than water. Okay, so you can't just base it on the temperature. You're going to have to look at the actual liquid. All right. So, why do you think this happened, Aaron? Why do you think that it mixed this time?
Like how come the water mixed with the
Yes.
Since the color water is hot, it goes up, and the cold water went down. Not all of the hot water went up. Some of it stayed down.
Oh, all the hot water goes up. But as it goes up, it has food coloring. As it goes up, the water comes down. Does the food coloring only stay with the hot water?
That's pretty
No.
cool.
That's why you have that mixture of color. Very good. All right. What is this model simulating? Well, this is an introduction. We're simulating what we call convection currents. Okay, and a convection current is basically a hot substance rising and a cool substance sinking because of density. All right. Now let's think of, where do we think these things can occur? Where do convection currents occur? Well, if we look at our essential question, we know two of those places. What are those two places?
Ocean.
Oceans and the atmosphere. Now, guess what? This is the reason of why we were studying continental drift. So where does this happen also?
Plate
Okay.
bender.
Plates.
Well, not just plates of time, it's what's under it.
the
The mantle. So I want everybody to go back to their page where we talked about continental drift, which should be page.
Is it the one where we did
130.
the?
So remember we did page 130, and that's where you did the little pieces right there. Remember that?
Oh,
That one of your questions was, why do you think this happens? So why do you think continental drift occurred? Now you know. Why do you think it occurred? Because what's happening underneath the plates?
They're moving.
The magma's moving.
Magma's-
The mantle's moving. The mantle has these convection currents, and as the mantle or the magma is coming up because it gets hot,
The plate.
okay, it kind of grabs onto the plate. So think of me as magma. The continent is right above me, okay? So as I'm getting closer and closer to the center of the earth, it gets hot, okay? So I heat up. If I heat up, now I'm less dense, what's gonna happen to me?
You go up.
I go up, I rise. So as I rise, I get closer and closer to the surface, okay, to the crust. That's cooler, right? So am I gonna cool off? So as I cool off, I kind of grab on to the crust that's above me, and I start sinking. So I start sinking. And then as I get closer and closer to the ground, or to the center of the earth, I heat up again, right? Once I heat up again, what happens to me?
Come back up.
I come back up.
So it's all cycles.
I grab,
Is that why they move so much?
and I come back down.
So little and
Yes, because it's a movement that's very, 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 very slow. Because the mantle technically is not a liquid,
like a rock.
and it's not a complete solid. It's a solid we call with plasticity. So think of, has everybody played with like silly putty?
Yeah.
Yeah.
Okay, so you take silly putty, and then whenever you press on it, and you can make it into a little ball, right? But if you leave it there on the table for a while, doesn't it kind of spread? So that's a solid plasticity. That silly putty is exactly like the mantle. When it's pressed, it acts like a solid. When there's not a lot of pressure, it acts like a liquid. So it's very, very slow in this movement of going down or sinking down, heating up, coming back up. And as it's doing that, it grabs onto that plate and moves it. And grabs onto that plate and moves it. So those plates are moving because of those convection currents inside the earth. Okay? So now you have your answer. Make sure it's in there. Okay? So, any questions over that? So now, what we're moving into, so we finished up Earth, or the inside of the Earth, and how it moves. Now we're looking at the surface, the convection currents that occur in the surface, be it in the ocean, or be in the atmosphere. So, yes?
We're gonna go over the atmosphere, mantle, core, outer core, inner core.
Like the actual layers? No, you don't really know that. Or no, you don't really. So, your assignment for the rest of the period is to look at answering your essential question, which is how do convection currents play a role in the ocean and the atmosphere. You picked up those 2 pages. Page 1 is the one that says unequal heating of Earth. That's the first page. And then page 2 is the one that has the land and sea breeze. So this is what I want you to do. And some of you have already started. You're going to do a dry read. Remember, a dry read is you just read it once without writing anything down. You just read through it. Okay? Number 2, number the paragraphs. And I want you to think about the paragraphs as you're reading, because you already read it once, right? I want you to chunk those paragraphs in paragraphs that relate to each other. So if you have 3 or 4 paragraphs that are talking sort of about the same thing, I want you to chunk them with a bracket. Okay? Now, let's say at the end of a page, you have one little paragraph and it goes with the stuff that's on the back. Just start the bracket there and end the bracket at the other end, on the other page. Okay? Number 3, in pencil, underline words that repeat. And I don't mean words like the, is, and, I mean science words. Okay? 4, in pencil, circle words that you don't know. The reason I want you to circle those is because on Monday when we talk about this, that is going to be your time to make sure you ask me about those words. Or, if you want to be an awesome student, you should look them up. That's what a dictionary is for. Okay? Number 5, highlight important phrases or definitions. Okay? Number 6, after you finish, I really want you to compare and talk about what you underline, what you circle, what you highlighted with someone else. Because that way you can actually hear it again. Okay? And then the last thing is going to be to write notes over what you marked. Now, you see what it says on page 137, use the markings? Use what you marked. So if you underline the word convection 10 times, convection should be in your notes.
Yeah. Equator.
Okay? So you want to make sure that if you underline a word over and over and over again, then it's probably an important word that probably needs to be in your notes. Okay? So use those markings, that's why we're getting you to mark the text. Alright? So any questions of what you're doing? So you have the rest of the period, which you only have about 10 minutes. Okay? And then Monday, I'm going to give you about 15, 20 minutes to finish. Okay? So any questions? Alright, go ahead and get started.
That was